So, as I was introduced in the beginning as the moderator for this session or symposium session, my name is Sarah Kulpa, and I am the restoration ecologist and botanist for the Reno Fish and Wildlife Office in Reno, Nevada. I am originally a New Englander, hailing from Massachusetts, but much to my mother's dismay, I accidentally fell in love with the Great Basin, and one field season of fun turned into 14 years and counting of work focused on native plants and restoration. So I'm going to talk to you all today about an experiment we have in the Winnemucca BLM district, building off of the presentation you just heard from Fred and Beth. And so I'd like to thank everyone that helped pull this thing together. All right, so Beth mentioned Rob Burton before in the previous presentation, and so there's a fun story to this. So Rob got all the seed increased, and you can see in the bottom left, there's this picture of all the seed coming in from BFI, and Rob was getting set to retire in I think it was the winter of 2018. And he said, guys, can we do something with this seed? So we pulled some things together and literally got seed, drove to Winnemucca, and they identified a couple spots on the Martin Fire, which was the biggest fire, I think, in Nevada history that burned through a bunch of untouched sagebrush habitat. And BLM on both the Winnemucca district and the Elko district wanted to do a bunch of seeding, and Rob was able to secure a couple spots for a test plot. And so that Martin Fire, you can see the green star on the map, that was over 400,000 acres, and it burned kind of where that star is and then burned east into the Elko district. He really, he got these sites held for us. And so we drove to the Winnemucca area, and one evening in a barbecue restaurant, Owen and I and Rob were scratching things on napkins, like coming up with our mixes and testing. And then the next day we drove out and did to put these seeds in the ground. And we were originally going to do 3 spots on the Martin Fire, but got foiled by snow. So had to think on the fly and change things. And the other fun part about this, it was 5 days to Christmas, and driving into the site, we had cell service, and we heard that the president was going to sign a federal budget. Coming out, we got cell service again, and we went into a government shutdown 3 days later. So somehow the stars aligned and we pulled this off. But I thought you would enjoy that pretty fun backstory. And because we did have success on that Martin Fire, we also seeded a similar experiment on 2 other fires on the Winnemucca district in the winter of 2019 at Rebel Creek and Sheep Canyon. And so Rob's successor, Andy Lacka, helped us secure sites there. And so really in this native seed production cycle, we're really talking about the seed procurement, seed storage, and then restoring those native plant communities. And so for our experimental design, we had 5 different things that we tried out on the ground. So we had a BLM Martin mix, which is the mix that BLM was using throughout the Martin Fire, and the Winnemucca BLM saved us some of that seed. And so that was a combination of commonly available cultivars of our native species plus a non-native Siberian wheatgrass. We had a local native mix that highlighted some of those species Beth talked about. So that increased Sonoma squirreltail that the Winnemucca BLM had, we actually physically put on site. And that same Poa secunda, or sandbird bluegrass that she mentioned, the Panther Canyon, that was also one that we were able to put right on site. And Rob also increased a blue bunch wheatgrass that was called Winnemucca. And Fish and Wildlife had increased some Great Basin wild rye. And when we increased the Great Basin wild rye, empirical seed zones were not developed for it, so we had to increase according to provisional, but now empiricals are available, but that is why you see on this figure provisional seed zone instead of empirical for that species. And so the block design is above, so we used a Truax minimum till drill, that was pulled behind a tractor. And we did 9 blocks, so 9 blocks of that image that you see up top in a 30 by 13 meters in a 3 by 3 grid. So we have 9 replicates on the ground of the BLM Martin mix, a drilled area that's no seed to see what the impacts of disturbance are without putting seed on the ground, a local native mix, and then a no drill, no seed control. And then we also partnered with the Nature Conservancy, and I'm not going to talk about this here, but I just wanted to show you and tell you what was in this. They did carbon pods. So these are something you're going to probably hear about later on in the second session. But within these carbon pods, which there's a photo on the bottom right of the screen, you can see in those the Sonoma squirrel tail and the panther canyon, 2 of the same species we use in the local native mix are contained within those carbon pods, and we put those on the ground. And so really what we're trying to test is really what Owen was talking about, the local adaptation in the first slide. So we're really trying to get to the question of there's no place like home. So just to give you an example, on your screen is you see the empirical seed zones for blue bunch wheatgrass. That's what all the different colors are. Our Martin test plot is the green star in the bottom within the Martin fire burn area. And that Martin test plot matches the same empirical seed zone as that Winnemucca source of blue bunch wheatgrass that Rob increased through BLM. The white star at the top that says Anatone next to it in Washington State, that is the source origin of the blue bunch wheatgrass that is commonly used throughout for restoration in the Great Basin. And so we are the 3A in yellow, testing, the same seed zone from the Winnemucca cultivar into the Martin test plot, which is also the 3A empirical seed zone. And that blue bunch is from zone 7B, so the purple. And so we're really, you can see a difference on this map of what it looks like, and we're trying to see what that difference translates to on the ground. And so just to give you some visuals of what this looked like. So in December 2018 is when we went and got out on the ground, and that's the burn area. It was black. You couldn't see anything, and it still smelled like smoke for a fire that burned in July. And you can see the snow on the ground, and that is why we could not make it down the road to other locations to do 3 replicates on this fire. June 2019, so that was our first year where we got monitoring data, and you can see that a lot of forbs are coming up. That's all natural recruitment in this coming up from the seed bank, and there's also a lot of residual native grasses that came up. And then you can see in June 2020, that was this year, we were able to get out a month, in the pandemic to monitor, and you can see that the site is filling in much more. And so I'm just going to show you results from the Martin fire, just some preliminary results from those 2 fires, because we have 2 years of data for that one, and it's got some, interesting preliminary results. So who is establishing? So when you look at this figure, the y-axis composition adds up to 100%, and you can see the percentages of seeds that were put in on the left-hand columns. So on the BLM mix, seeds in is color coordinated to the different grasses that were actually composed that seed mix. So you can see that their mix composed a whole lot of Sandberg's bluegrass, a little bit of blue bunch, very, very tiny amounts of squirrel tail and Great Basin wild rye, and a small amount of Siberian wheatgrass. But then with the plants that came up, looking at the data that we started to collect, you can see that small amount of Siberian wheatgrass translated into a big amount of Siberian wheatgrass on a landscape. And that big amount of Poa secunda that went in, the Sandberg's bluegrass, that translated to a small amount of what actually established on the landscape. Compared to the native mix, there's a little bit more of a balance there, where certain species did do better. So the seeds in, we put a lot of Sandberg's bluegrass in. We got, a smaller amount out than what was put in, but still a much closer ratio than the BLM mix. And we put in a smaller amount of squirrel tail and got much more squirrel tail out. So that's probably my favorite. And I want to show this to you in a visual. So when we went out and were monitoring these this June in 2020, my husband wanted to get out of the house because, COVID pandemic. So he came and he flew his drone for us. And if you look at this, you can see us standing down on the landscape, and you can see the tape. You can see the tape where we're taking our monitoring plots along it. And you see those really bright green areas right here along the tapes. That's the Siberian wheatgrass. And we saw this spotty pattern of the non-native establishing. So all these big spotty areas of green that you see that are much taller than all the other grasses, that is the establishment of the Siberian wheatgrass, the non-native, and in that BLM mix. And it was obvious on the ground, but I really like this aerial because it really showed from a bird's eye view of what we were seeing wandering. And it really helps explain what we were seeing in this figure. All right, so this one's a little more complicated, but I'm gonna walk you through it, but it's also exciting. So along the x-axis are the different treatments. So the BLM is that mix of the standard non-native Siberian wheatgrass plus the commercially available cultivars of our native species. The native mix is that local native seed from the Winnemucca district. NSD is no seed drill. And then NSND is no seed, no drill. So that's like the full control. And then along the y-axis is the number of plants that are establishing per meter squared. So the first bar I want you to look at is this blue bar. And this is the number of plants that established per meter squared for both of those seed mixes that we were testing and got one against each other. And so right now you're seeing a similar amount of plants per meter squared that established, and that's roughly about 10 plants per meter square. However, the BLM mix was seeded at a much higher rate. So when you do the calculations, BLM was putting down about 1,220 seeds per meter square, and we were putting down 714 seeds per meter square. So a little more than a difference of a half, right? But this is just showing you that they might, even though they have a much higher seeding rate of this BLM mix, we're still getting similar results in terms of in terms of seeds that are turning into plants. And so far, this data is showing that local native seeds are more efficient because fewer seeds are needed for that similar establishment, which I find really fascinating. I'm not going to talk much about the red bars or the green bars, but the red bars, for those that are interested, is showing you cheatgrass establishment between the different treatments. And then the green bars are the non-seeded native grasses. So those grasses that either resprouted or established from the seed bank. But I do want to point out these purple bars. So these are the means of the non-seeded perennial native forbs that reestablished from the seed bank or resprouted from roots. And this is interesting because it's showing that perennial native forbs don't like drills, and they like the seeded species in the BLM mix the least. So you can see in this, we had the highest proportion of native forbs establishing on the landscape in the control where there's no seed and no drill. The next highest, of course, was in the no seed and drill. And then you progressively go down as you look at the different mixes. And so the BLM mix that had that non-native and those other cultivars in it was also allowing the least amount of native forbs to reestablish from the seed bank. All right, and just to show you some of those other fires quickly, this is what they looked like on the ground. So in December 2019, this is what it looks like when we seeded it. And then in June 2020, this is what we were starting to see along some of the transects. And the thing I did want to point out that was fascinating from this one is my husband flew aerial at this one as well. And this black box kind of here where it's like burnt, but you don't really see the rows, this is where our experiment is, and this is the Truax drills that we use, the minimum trill Truax again here. But this is the range drill around our site that was used to seed the standard BLM mix that they were seeding on this Rebel Fire. And it was just fascinating to look at it from an aerial perspective of the two differences in terms of ground disturbance from that perspective. So I just wanted to share that with everyone on here. And then this is what the Sheep Canyon one looks like. And so Sheep Canyon, again, pretty charred, some shrub stem remnants in December 2019 when we seeded. And then this is one of our native mix transects that Allison and Kathy are taking data on. But this one was interesting because forbs were coming up, but they had Mormon crickets come through. So I think if we had gone out earlier, we would have saw, you know, more things on the ground. But I think the Mormon crickets kind of had their way with some of the species on the site. So I'm curious when we have more data what that's going to look like. And so really our next steps are monitoring, and we're hoping to get some more data next year and get some of our results pushed within the next year or two. And with that, like I said, it took so many amazing humans to pull this off. It was crazy how we did this, but I think it just shows the strength in partnerships and collaboration that we were able to make this happen. If you do have any other questions for me, I put my email and work number on the screen. And so that's the best way to get a hold of me. But I'm going to exit the screen share right now so that we can see if there is any questions.
Sarah, this is Lisa. I can ask you a few if you'd like.
Sure.
We did have a few, and you've got about 3 minutes.
Okay.
The first one came from Maggie Park. Do you know how the empirical seed zones were generated?
That is a perfect question for our next presenter. So I'm not going to steal Francis's thunder, but I think Francis is going to dazzle you with that information next.
Super. Okay, and then the next question from Owen, would you expect the range drill disturbance to have an even larger negative effect on native forbs than a Truax?
I would after seeing that. So I'd be curious to look at that. So maybe that can be one of our next schemes, Owen.
All right. And then from Terry Hogan, does Siberian wheatgrass dominate for a number of years, then is outcompeted by natives, or does it remain a dominant species? That's the first question. And then the second is, why is it included in the seed mix to establish cover quickly?
So yes. So I actually don't know how Siberian's going to do in the seed mix. And so that's something we're hoping to get from monitoring. It is a different life form than our native grasses. So the ones that we were talking about a lot, the squirrel tail, the Poa secunda, or the Sandberg's bluegrass, the blue bunch, those are all bunch grasses. But the Siberian has more of a rhizomatous characteristic. And so I'm wondering if that might be why it kind of forms those big clumps when it does get a establishment footing. But I'm hoping, you know, as we monitor these sites, we're going to be able to tease some of that out. And typically it's included in the seed mix. I mean, these non-natives, crested wheat, Siberian, forage kosher, these are things that are typically used in a lot of the seed mixes in the Great Basin because forage and to establish cover quickly.
Okay.
And that's something we can probably talk about more in the facilitated discussion session, because I feel like a lot of presenters might have more to say on that. So that might be something we can talk about more after the end of our 11th presenter.
Okay, great. And then Patricia DeAngelis was wondering if you could just mention again what the next steps are, and then that should take you to your next speaker.
Okay, so our next steps are just to continue monitoring those sites. And I really think this is going to show some promising data. So monitoring the hell out of the sites that we've established, but maybe working with partners as well to kind of establish more of these sites as more locally adapted native seed becomes available, and just kind of keep setting up these test plots around the Great Basin to show that, you know, local natives are where it's at.